Welcome back to the channel, everyone. Now we're going to take our knowledge of charts and using these charts to solve perimeter and area problems. Two things to remind ourselves about. We're going to be talking about specifically more rectangles today. So we need to know our rectangle formulas for area and perimeter. Perimeter formula is this 2 length plus 2 times the width. And our area formula is just length times width. So these are the values that we're going to be using in our table. We're going to be using length and width. We just need to know what the last label over here will be. Is that going to be either A or is that going to be P for perimeter, area or perimeter? So that's what we're going to figure out in this problem, and then we'll use these to our advantage a little bit later. So the length of a rectangle, if I'm reading carefully here, the length of a rectangle is 6 centimeters longer than the width. The length is then increased by 9 centimeters. The width is increased by 5 centimeters, and the perimeter will then be 160 centimeters. So that instantly tells me that the variable I'm using over here is perimeter. It also tells me that I'm using perimeter formula. So there's my perimeter formula. I'm going to slide this over for the time being. I'll keep that off to the side. Okay? We need to find the dimensions of the original rectangle. So that is important to know because that tells us our other labels here are we want the original rectangle versus what I'm going to call the new rectangle, the new dimensions, okay? So now we can start filling out our chart, okay? We do know that the new rectangle has a perimeter of 160 centimeters, okay? We do not know the dimensions of our old rectangle, so we can't know that perimeter. That's perimeter P, okay? We also know that going to the original rectangle is 6 centimeters longer. Its length is 6 centimeters longer than the width. So that tells me that I actually don't know my width here, but I do. It's actually W, okay? So my width is unknown. I give it a variable, meaning if the length is 6 centimeters longer, I would take my width and add 6 to it, whatever that value would be. Now I go to my new rectangle. So here, now I do a little bit more calculations. They increase the width, the length, which in this case is width plus 6. They increase that by 9. So I'm just going to add the 9 to the 6 here, combine my like terms, make a width plus 15. And then they increase the width by 5. So you just have to take this width and increase it by 5, W plus 5. So I ask myself, where do I actually have more information to solve an equation? It would be with the new rectangle. Okay? So that's what I'm going to substitute in to my formula over here. So I'm going to take 2 times W plus 15, and then plus 2 times W plus 5, and that is going to be equal to my perimeter here, which is 160. Okay? And then it's just solve your equation. So now I'm going to erase that, get that out of the way. We're going to distribute in here. So I get 2W plus 30 plus 2W plus 10 is equal to 160. And then I just start solving. Combine your like terms. 4W plus 40 equals 160. And then solve the two-step equation from there. I'm left with 4W, ran out of space, is equal to 120. Divide both sides by 4. So W is equal to 30. Okay? So that would be 30 centimeters. We want to make sure that we have our units here. Okay? So that's my width in this case. And I have to find the dimensions of the original rectangle. So if my width is 30, this over here would be 30 centimeters. I would take W plus 6, and then my length is going to be 36 centimeters. I must have my units in there. Okay? So that's a perimeter problem. Next example, we're going to look at an area problem. So here we have 2 gardens. Again, we're going to label up here length, width, and this is actually talking about the area here. So now I'm talking about a rose garden. It is 9 feet wide, so I know that's my width, 9, and it is 30 feet longer than a garden 15 feet wide. So this is a second garden. I know the width is 15 feet. Put my units in here so I know. And I know that the length is 30 feet longer in the rose garden than the other garden that I have here. Okay? So if I had that, I don't know what this length is. It's just L. Up here, 15 feet or 30 feet longer would be L plus 30. Okay. Now it does tell us that each garden, both gardens have the same area. So that would be the area A, in which both of them, we have an equation where A equals length times width. Okay. We're going to go back to that principle of using the transitive property here, because what I actually have is I have one garden where area, if I just multiply in here, is 15 times length. The second one, the one up top here, I'm going to use distributive property. Area equals 9 length plus 270. They both equal the same variable, meaning these two equal each other. So I can write that equation. 15L equals 9L plus 270. And now just solve your equation. Subtract your 9L from both sides. You got 6L equals 270. Divide both sides by 6. So the length ends up becoming 45 feet. Okay? So we're trying to find the dimensions of each garden. So if this length is 45 feet, so the actual garden, the second garden, was 45 feet by 15 feet. That's garden number 1. The second garden, we're going to substitute in here, which means we have a length of 75 feet by a width of 9 feet. And if you wanted to check, that would be the rose garden. If you wanted to check this, you could just substitute in and confirm that they would have the same areas. So if I actually multiply these together, 75 times 9 equals 675, and then 45 times 15 is also 675. So that's kind of your check to make sure that your answers are actually correct.